Here we want to calculate the heat transfer effectiveness of the fin surface. So by definition, the effectiveness of the fin surface is the ratio between the total heat flux that we get from this fin surface divided by the one we would have without the fins. So in fact, the lower side of this ratio corresponds to the case we had in part B of this exercise, where it was just a bare tube that was used. So how to express this heat flux? This heat flux is equal to the heat transfer coefficient, so the convective heat transfer coefficient. In our case, it's H out, the one we have on the other side of the tube, multiplied by the difference of temperature between the hot fluid and the external wall of the pipe. So with the first nomenclature, so it's T hot minus T wall outer surface. But with the little schematic you have there, it can also be written T infinity minus TB, and TB is for the base and infinity is for the fluid, the temperature of the fluid far from the surface. So for the fin surface, the heat transfer area on which this convective heat transfer is taking place is first what we call the unfinned surface. So it's the outer wall of the pipe between the fins. That's what we call A unfinned. Plus the surface of the fins themselves, but because here we take the temperature of the base as a reference, we need to weight this surface by the efficiency of the fins that we have calculated before. For the no-fin surface, it's the same heat transfer coefficient, the same difference of temperature, and here it's the surface area of the outer wall of the pipe without fins, so what we had in the first in the previous section of the exercise. So we see that we can simplify this by dividing by removing the heat transfer coefficient, because we consider it the same, and that's quite a big approximation also to consider then that without whatever the orientation of the surface, we still have the same convective heat transfer coefficient. It's quite a big assumption, and we also remove this delta T, which is considered as the same. So in order to calculate the efficiency of the fin surface, we need to calculate now these three surfaces. So in order to express the surfaces, we have the length of the fins that is appearing, and we don't know the length because we will design it, but anyway we just want a ratio, so we can take any length for the calculation of the efficiency. I suggest to take as a basis a length of 1 meter, because we know that we have 200 fins per meter, and so the surface without fins, that's just the surface of a cylinder, and we can calculate the value 0.0942 square meter. Then the area unfinned, so the area of the tube between the fins, this time it's 200 times the surface that we have between two fins, because we have 200 fins per meter, and here we find 0.0565. In fact, we get a bit more than half of the no-fin surface, because we have 3 millimeters between two fins and 2 millimeter thickness for all the fins. so it's a bit more than half of the surface. And finally, the surface of the fins themselves. We have two components for the surface of the fin. We find here the surface of the each side of the fins that are perpendicular to the pipe direction, and also here we need to take into account the surface that is on the outer ring of the fins. And so we can calculate for 200 fins because we have 200 per meter, and we find a much higher surface. In fact, we get 10 times the area that we had without fins, so 0.942 square meter. And now that we have calculated all these three surfaces, we can calculate the efficiency of the fin surface, and we find 8.81. So it means that our surface is now almost 9 times more effective than the outer surface we had before.